Picture this. You're standing on a beach in Polynesia. 3,000 years ago, no compass, no GPS, no satellite blinking somewhere above your head, just you. A canoe made of hollowed wood, and an ocean that stretches so far it looks like it swallows the sky. And yet, you're about to sail 2,000 miles across open water, on purpose, and you're going to find a tiny speck of an island when you get there. Sounds impossible, right? Like something out of a movie. But this actually happened, thousands of times. And the people who did it weren't lucky. They were something far more terrifying to modern scientists. They were accurate. Here's the part that should blow your mind. Modern researchers, armed with satellite data and supercomputers, have spent the last few decades trying to figure out how ancient civilizations mapped the world with such stunning precision. And honestly, we're still not 100% sure. We're basically reverse engineering the minds of people who died centuries before. Newton figured out gravity. Let's rewind further. Long before Polynesian wayfinders, there's a stone tablet sitting in the British Museum right now, the Babylonian Map of the world, carved around 600 BCE. It's small, cracked, unassuming. You could walk right past it in a museum and never know you're looking at one of humanity's first attempts to draw the entire known universe on a piece of clay, rivers, mountains, mythical lands beyond the ocean, all etched by hand using nothing but observation, memory, and belief. Now here's a question that should sit uncomfortably in your chest for a second. How do you draw something you can never see all at once? You can't fly above the earth, you can't zoom out. You're standing on the ground, limited to what your eyes can catch on the horizon. And yet, generation after generation, humans kept building maps that got closer and closer to reality. This is where the story gets personal, because mapmaking wasn't just about geography, it was about survival. A wrong turn in the desert meant death by dehydration. A miscalculated ocean route meant your entire crew disappearing into nothing, swallowed by a horizon with no name. Every mistake on a map wasn't just an error, it was a body count. So ancient people developed something modern psychologists now find genuinely fascinating, an internalized, almost supernatural sense of spatial memory. Polynesian navigators, for example, didn't use instruments. They used their bodies. They'd lie down in the bottom of a canoe and feel the ocean swells vibrating through the wood, distinguishing between different wave patterns bouncing off distant islands, sometimes islands they couldn't even see yet. Scientists studying this today call it mere wave piloting, and honestly, cognitive researchers still can't fully replicate the skill in a lab. Now imagine being a kid in that culture. From age 5, you're taught to read stars like a language, not memorize them, feel them. The position of Polaris, the rising point of specific constellations tied to specific islands. Your bedtime stories are actually secret navigational codes, passed down not in books but in chants and songs, because paper didn't exist and memory was the only hard drive available. This is the raw, human core of the story. Mapmaking wasn't a science born in comfort. It was born in fear, necessity, and obsession. It was humans refusing to accept that the unknown had to stay unknown. And it makes you wonder, in a world where we now have Google Maps guiding our every turn, have we lost something ancient people had mastered? That instinct? That deep, primal relationship with direction, distance, and the sky above us? Let's get into the mechanics. Because once you understand how ancient mapmakers actually did this, it stops sounding like magic and starts sounding like one of the most underrated feats of human engineering in history. Start with the Phoenicians, roughly 1200 BCE. These were the first true professional, long-distance sailors, and they built something modern logistics companies would envy. A mental network of coastal landmarks, star positions, and current patterns stretching from the Mediterranean all the way to the edges of West Africa. They didn't have paper charts on their ships most of the time. They had repetition. Route knowledge was drilled into sailors through apprenticeship, the same way a modern pilot logs thousands of flight hours before flying solo. But here's where it gets scientifically wild. Around 150 CE, a Greco-Roman scholar named Claudius Ptolemy did something almost absurd. For his time, he tried to create a coordinate system for the entire known world. Latitude, longitude, a grid laid over reality itself. Without satellites, without airplanes, using nothing but travelers' reports, trade records, and mathematical extrapolation. Modern GIS researchers, the same people who build the mapping software behind Google Earth have gone back and analyzed Ptolemy's calculations. And the unsettling part? A huge portion of his relative distances and angles were remarkably close to accurate, especially considering he never left the Mediterranean region himself. He was essentially crowdsourcing geography centuries before crowdsourcing was a word. Now let's talk about a discovery that shook historians only a few decades ago. The Marshall Islands stick charts. To an untrained eye, these look like a toddler's craft project. Sticks, tied together with shells attached at certain points. But to a Micronesian navigator, this was a full 3D simulation model of ocean swell patterns. The sticks represented wave interference patterns caused by islands disrupting open ocean currents. The shells marked island locations relative to those wave distortions. Think about that for a second. These people weren't just mapping land. They were mapping invisible energy patterns in water, something we now study using an entire field called physical oceanography. With buoys, satellites, and wave modeling software, they figured it out with sticks and shells and a few thousand years of trial, error, and death-defying voyages. Here's a mind-bending modern parallel. NASA and oceanic researchers have actually studied Pacific Islander navigation techniques to improve autonomous ocean drone pathing algorithms. Let that sink in. Ancient survival wisdom is currently informing 21st century robotics. Then there's Polynesian star compasses, a 32-point mental system, dividing the horizon based on where specific stars rise and set. Cognitive scientists studying wayfinders today have found something remarkable. Their brains show unusually high activity and connectivity in the hippocampus, the brain region responsible for spatial memory, or similar to what researchers find in London cab drivers who memorize the city's entire street layout without GPS. It's not myth, it's neuroscience. These navigators had, quite literally, trained their brains into biological GPS systems, and this is where human psychology enters the story. Why did these methods survive for thousands of years without being written down? Because the human brain is shockingly good at retaining information, wrapped in story, rhythm, and emotional stakes. Chants, songs, rituals before a voyage. These weren't just cultural flavor. They were memory encoding techniques, disguised as tradition. Long before memory palaces became a trendy productivity hack, ancient navigators were living inside one. But it wasn't only about the stars and waves. Ancient Polynesians also read birds, knowing which species flew out to sea at dawn and returned at dusk, using their flight paths like living compass needles pointing toward hidden land. They studied cloud formations, because clouds often cluster differently. Above islands due to heat, reflection off land compared to open ocean. They noticed subtle color shifts in water depth, distinguishing between deep ocean blue and the lighter hue, caused by shallow reef systems near land. Every single one of these techniques required obsessive, generational attention to detail, so one mistake didn't mean a bad grade on a test. It meant your entire village might lose contact with a trading partner forever, or a fleet might vanish at sea. This is the real story behind ancient mapmaking. It wasn't one genius invention. It was millions of small observations, refined generation after generation, until an entire civilization's survival depended on humans becoming living instruments of measurement. Here's the twist: most people never expect when they first learn about ancient mapmaking. These civilizations weren't behind us. In some ways, they were solving problems we still haven't fully cracked with modern technology. Think about it. GPS satellites can fail. Signals can be jammed, blocked, or lost entirely in remote regions or during solar storms. In fact, militaries and search and rescue teams today are quietly retraining personnel in old-school celestial and terrain navigation, specifically because satellite systems can be disrupted. In 2016, the U.S. Naval Academy reinstated celestial navigation training for officers after realizing an over-reliance on GPS created a dangerous vulnerability. Let that sink in. One of the most technologically advanced militaries on Earth went back to reading stars, a skill perfected by ancient sailors thousands of years earlier. That's not nostalgia. That's a warning. Here's the deeper, slightly uncomfortable truth researchers in cognitive science keep circling back to. Our brains used to be sharper navigators than they are now. Studies on GPS dependency have shown that people who rely heavily on turn-by-turn directions show reduced activity in the hippocampus, the same brain region ancient wayfinders had supercharged through years of active navigation. In other words, the very tool designed to make our lives easier maybe quietly shrinking one of our most ancient cognitive superpowers. So picture this modern hypothetical. Imagine your phone dies in an unfamiliar city. No signal, no map app, nothing. For most of us today, that's genuine panic. But for someone living just a few hundred years ago, that was Tuesday. They didn't fear the unknown the way we do. They were trained for it. From childhood, through story, repetition, and necessity. This is the emotional core of the whole story. Ancient mapmaking wasn't really about geography. It was about human beings refusing to be lost, refusing to let the vastness of the unknown control their fate. Every star chart, every stick map, every carved clay tablet was an act of defiance against uncertainty, a way of saying, we will understand this world, even if it takes generations. And weirdly, that mindset is making a comeback. Bushcraft schools, survivalist communities, and even some university geography. Programs are now teaching celestial navigation and natural wayfinding as a form of cognitive resilience training. Not because GPS is going away, but because people are starting to realize that outsourcing every mental function to a device has a cost we're only beginning to measure. Here's the surprising truth to leave you with. The ancient world wasn't primitive. It was precise, just precise in a language modern society forgot how to read. Every wave pattern, every star position, every bird's flight path was data. Real, testable, repeatable data, processed by the most sophisticated computer ever built, the human brain, trained relentlessly across generations. So next time your GPS glitches or your signal drops in the middle of nowhere, remember this: somewhere in your ancestry, someone crossed oceans, deserts, and unmapped wilderness using nothing but the sky, the water, and unshakable human will. Maybe the real question isn't, how did they do it without satellites? Maybe it's, what did we lose the moment we stopped having to? If this story shifted how you see the world, drop a comment with the one fact that surprised you most, and subscribe. Because next time we're uncovering another secret that history almost let us forget.